My name is Shiv. I'm going to explain in this video about object-oriented programming. In short, we call as OOP. Before starting, I want to tell you a little bit about myself. I have been graduated in computer science and engineering. I have been working in IT industry for last 10 years and been involved in multiple type of product development cycle. I am a agile practitioner. These are my contacts, email address, phone number and LinkedIn where you can reach out to me for any kind of clarifications and questions. This is my agenda. I'm going to explain what is OOPS, then we will come to why object-oriented programming is required. I will use the terminology as OOP here on to replace object-oriented programming in short for simplicity. So what I'm going to explain in this video is that is first one I will start with what is OOP, then why OOP, then I will tell you a little bit history about OOP, then I will go to the detailed concepts of OOP, and in last I will explain what are the programming languages that support OOP. So let's start with something called what is OOP. OOP is the concept which is based on object. What is object? Object is nothing but anything what you see around you that has some properties, you can say characteristics or attributes, and that object performs some activities on those attributes. For example, college, you have a college, you can take college as a object which has some attributes like name, location, and type of the building, type of education, what affiliation it has, in which which university it has affiliation to. These are the few properties, and there are few action. It does some admission, it does teaching, it does placement, and a lot of stuff. So these are the some activity that college object performs. But you have something called body object also. Your whole body you can call as a object because it has a lot of attributes like your hands, your mouth, nose, hair, mind, and it performs some activities like it touches, it smells. So this is also a object. In fact, any part of body itself you can say as a object which may have some certain kind of attributes and and performing some activities on that. Say suppose your hand is the object. It has say fingers, it has some color, it has length, it has how many what is the, and it has some sorts of activities. The movement is the activity. Your hand does some movement, your hand does some finger movements. So these are the some activity that it performs. So this is also example of object. OOP is a non-procedural approach which is a called modular approach. Modular approach means you can think of like objects, and you can club those objects to make a model. So if you are thinking of a big problem, or if you are thinking of a big project, or say big system where you can divide the whole system into different modules. So object oriented programming or OOPS, it will give you a opportunity to think in the direction of modules. So the modular way will help you to achieve the things easily. So it provides model based on the real world problem. So increase flexibility and maintainability of the program. So if you have big program where you can divide whole program into different modules, so working on each module will be easy and you can easily maintain, and that's very much flexible. Why? Because you can work on an individual module, and slowly you can move to next one, and once you complete you can move next one. So that is very much flexible and maintainable. Communication among objects. Any system where you have a lot of objects, they need to communicate among them. Without communication, the purpose of application cannot be fulfilled. What does communication mean here? Here, sending the message to and from the object. Sequential operation. OOP is a sequential operation. So object A, there are say set of objects in a program or in a project or in a module. Those objects communicate to one another. So object A sends message 1 to object B, B sends message 2 to object C, object C sends message 3 to object D, D returns message 4 to C, and C returns message 5 to B, and B returns message 6 to A, object A. So you can see that it is a certain communication is happening to make this flow working. So we have got like what is object here. Let's move to the why object. Sorry, why OOP. So why OOP means why do we need object oriented programming model? Why not something else? Why it is better than other model, other programming model? So why it is, first reason is like human thinks everything as an object. Suppose you are thinking of a problem, you are thinking of your own house, you are thinking of your school, you are thinking of your book, you are thinking of your pen. So everything that you are thinking as an object. It means that whatever you are thinking, it has certain attribute and it performs some kind of activities. So human thinks as an object. So that's reason it is pretty much mapping to this concept. It implements object-oriented analysis and design. What does it mean? It means that you are grouping a lot of objects to design a module and to analyze your object while designing them. So this OOPS concept is going to help into doing analysis and design, which is object-oriented. It uses objects as its fundamental building blocks. So suppose you are making a modules, so you are clubbing few objects to make your building blocks. So you are thinking elementary and then summing up them all and making something bigger. But your fundamental is still based on the objects only. Associates data structure with its operator which act upon it. Suppose you are doing some operation between two objects. You are trying to do some equal. You are trying to suppose, for example, you are trying to compare few objects, one object to another one. So while comparing is the operation, and you might be using some operator greater than or less than. That is the operator. So while applying those operator on those objects, object-oriented programming uses data structure to give the result of those comparison. This is the another reason why we should go for object-oriented programming. And most important thing is like this is a solution of procedural approach, procedural programming. So before OOPS, there was programming model kind which was called procedural programming model. So where whole program was designed top to bottom. So it is going step by step from top, next, then middle, then bottom. So this is that was the procedural approach. The issue was with that kind of approach was low software maintenance. If you are skipping any steps in your procedure, it can mess up whole program. And of course, if it is you're going top to bottom approach, it is taking more time than if you go for object-oriented programming. Change made to the main procedure top may impact all procedures in the pyramid. So suppose in the pyramid you are having on top some programs, and those are used by their callers, and their methods will be used by their callers, and so on. So if you are changing something in that pyramid, means in your steps, in your flow, something you change, then it may impact the others. So this is not a modular approach of doing the programming. So OOP basically helps to eliminate these kind of complexities and make the solution in the simpler way, where you can think of everything in an object, building blocks and modules. There are other few reasons why we go for OOP. It insists that you think what to expose to outside world. Suppose you are thinking of your object. Here you have capability to restrict the properties of the object, what I should show outside of object, what I should not. So that concept is provided by OOP. It also allows to have many different functions with the same name doing different jobs. So suppose you have add method which is taking many parameters, or which is taking some strings which are taking some float value, double value, where you are trying to add two strings, means adding two strings means you are doing the concatenation of those two strings. Suppose you are taking my name is first parameter is Shiv, second parameter is Prasad, and you are doing concatenation, that you will get the result of Shiv Prasad. Same time you are adding two integers like 3 and 5, you will get the result of 8. So here suppose I say there is one method called addition, where you are parsing different kind of parameters. So you have multiple methods with the same name, but they are performing different kind of they are taking different kind of arguments and trying to give a result which is the addition of those parameters. So this feature we call as a polymorphism in OOP. Next one is it allows generic code. So by using object-oriented programming, you can go for writing the generic code, where you will write once and which will be implemented and read many times, where you have centralized piece of code that is written in very much generic, which is helping other program to go for their own implementation. So that way OOP will help. It allows to write a set of function that spans from them in that spends them in different direction without changing or copying them in the way. So suppose you have this concept we call the inheritance. Suppose you have certain properties of a object and you want to inherit that in your own object. That one you can do in OOPs. So whatever properties you have in parent object, that will be inherited to the child, and child can has their own implementation also. And because of this inheritance, it uses the component reusability. So reusability is very important feature of OOP. OOP history. We are using OOPs from last many years. We have used OOPs in C, and now we are using Java, a lot of other programming languages which are also supporting OOPs. But first time in 1960 we called as a first object language. Till that time we have not given the name as a object oriented language. It was just object language. That was Samuel, the name of that language, and that was used for simulation of the machines. From this use of those language, that name was given as Samuel. The term object oriented programming was first used by Xerox company in their small talk programming language. So you can say that Xerox was the first company which gave the name as object oriented programming. And nowadays we are extensively using this concept almost in every industry, not necessarily IT industry, maybe in manufacturing and other kind of industry also. There we are thinking of every problem as every module as a set of objects and trying to achieve the things by building the blocks and modules. Elements. OOPS has two main elements. One is class, one is object. Object and class, everything is inside the OOPS is moving around these two elements, object and class. If you see this picture, what is class? Class here is a pictorial way of showing the object. So if you see here class, we have class student, name, it has name as attribute, roll number as attribute, and two methods, set name and set roll number. The purpose of set name is setting the name of the student, and purpose of set roll number is setting the roll number of the student. And what is the object here? Object is an instance of the class. So if you see the object here, Gina, John, Maria, James, these are names, and R05, 010, R029, R0009, these are their roll number. So every object is the instance of class, and class is the pictorial way of presenting the object. If you see here, there is something called class as a car, where you have object 1, object 2, object 3. So you can say that car 1, car 2, car 3. So car is the instance of car, object is the instance of car class. In the right example, if you see that healthcare professional, this is the object, healthcare professional. ENT is also one kind of healthcare of professional, nurse, medical doctor, pharmacist, surgeon, radiologist, and pediatrician. So these are the they belong to a class, and object is instance of that class. So in this example, what we see here, we have an object which has data member and functions. So in this object, you can see that there is a lot of variables in that class and function on that. So to summarize class and object, object is runtime entity of object-oriented system. An object can be a variable, it can be a function, you mean to say return type of the function, or parameter in the function, or any data structure like hash map, hash table, array, linked list. Object refers to a particular instance of class. That's what it again said. Object is a instance of class. Object has lifespan, but class doesn't have. What does it mean? So when you create an object and use it, and after use you just destroy it, so it has some lifespan, but class doesn't have. So class is a blueprint or prototype of the object, or you can say it is a pictorial way of object. This is the most important slide for this OOPS course. You can see that there are a lot of concepts which are used in our real-time problem: encapsulation, inheritance, abstraction, polymorphism, message communication, delegation, persistence, dynamic binding, which is combination of inheritance plus polymorphism, and object life cycle. But out of those concepts, first four concepts are very frequently used. Others are kind of, you can say that, derived kind of concepts. So I am going to explain each concept in detailed way. So let's first start with encapsulation. So encapsulation is a data binding. So if you just see this example and assume this one as a object, so it has data, which is nothing but properties, attributes, and some methods around those data. So it takes input, process it using their data and logic written into the method, and gives one output. So encapsulation is something concept which encloses the data. It looks like it is a capsule where it is binding the data with its function. So it binds data and function into one place, that is called class. So encapsulation provides one mechanism to restrict access of some of the objects, attributes or components to outside of object. This particular methodology is called data hiding. So encapsulation provides data hiding. Suppose you have any object, say for example car has some color. You want to show the color to the anyone who is seeing car object. So this is what you are making your that color of the car is visible to outside. Same time you are having some internal hidden characteristics which user cannot see. So that way you can restrict the visibility of any component of the object. So it helps to make object right or protected. Suppose you want anyone can only do the read operation on your object or can do only write operation on the object. That way of protection you can achieve by encapsulation. Second concept is inheritance. Inheritance is the concept where you are deriving some property from the existing object to make a new derived object. So for example, if you see here, there is object, that is vehicle class. So vehicle class, it has some property ID, name and license number. So there are two classes which are inheriting this base class. Other two classes are two-wheeler class and four-wheeler class. Two-wheeler class, if you see, it has three attributes which are common from vehicle class, that is ID, name and license number, but it has steering handle, and in case of four-wheeler class it has a steering wheel, which are different from the vehicle class. So what you can say that it is inheriting few properties from its parent class and then adding some more extra to its own class, right? So it is giving the concept of reusability. Second example, if you see, that is class bicycle, and which is being extended by other subclasses like mountain bike, road bike, tandem bike. So these are three child classes which are inheriting some properties from its parent class. To summarize it, when a class is based on other class, that is the place where it is called inheritance. It brings property to its parent and can add more to itself. So it is basically inheriting some few properties from its base class and adding something more on that. It gives concept of object hierarchy. So suppose you are some object is inheriting its parent class is inheriting its grandparent class. So in this way there is a hierarchy maintained in that inheritance. The relationship between two objects which is defined over here is called is a relationship. Coming back to this example again, if you see here, two-wheeler is a vehicle. So the relationship between two-wheeler and a vehicle is a relationship. Same time, four-wheeler is a vehicle. You can say mountain bike is bicycle, road bike is a bicycle, tandem bike is a bicycle. So the relationship what is maintained over here, that is called is a relationship. If there is a relationship, that is a place where inheritance has to be placed. What is the benefit of inheritance? That is, as I said earlier also, reusability is the very much important benefit of inheritance. Along with that, it has benefit of dynamic polymorphism. So where you have defined few characteristics in the base class, so that child class is inheriting that and they are adding the implementation their own way. Suppose your parent class has some method called say uh, print string. Now the child classes which are inheriting those parent class, they can override those method and print string their own way, and that kind of phenomena is called dynamic polymorphism, that is achieved by inheritance. Next concept is abstraction. If you see this example, a buyer or car car user, or you can say buyer, he is not aware of what is the complexity of a car inside, how engine works. He just need to use it. On the other side, engineer knows how things are working inside. So abstraction is the concept where you are letting user to focus only very limited side of the object, not on the complex side of the object. So you are not needed to know about internal complexity of the object. You have just to focus on very minimum things for the object. Abstraction, only the essential characteristics of the system being studied are modeled. Minor and irrelevant details are ignored. So it supports generalization. How? Suppose you are doing some implementation, but the class which is extending this property, they can use that method in their own way. So you are providing some generic approach for this object oriented programming. It supports generic, yes, it supports creating the generic modules, separation of declaration and its implementation. So you just declare the behavior, and whoever is looking for that object, they can do their implementation. It provides a lot of flexibility. It is open for extension, so you can extend it this class and write the implementation, but close for modification. So it is giving one way to not to modify the base behavior. What you can do, you can extend the object and write your own behavior. It is very good and effective if abstraction is combined with encapsulation. So where you are providing the data hiding, data binding concept along with generic approach. So all the things what we are achieving by abstraction, that is to make our work simpler. Polymorphism. Polymorphism is the concept where you have the same name but behavior will be different. That is called polymorphism. You have same name but the action, the way you do the action, that is different. Suppose speak is the name, is the verb, and the way different creature speak, that you can see here. how cat speak, how a person speak, how other animals speak. So polymorphism is ability to take on many forms. Most powerful advantage of object-oriented programming. It has one name and doing many operation sorry one operation and many methods. So operation name is same, but there are multiple methods which are performing different kind of activity based on the what input it accepts. Polymorphism is kind of one interface and many possible implementation. Suppose you are having some certain set of rules which you are defining for some process, and a lot of classes which are implementing those behavior. So that way you are writing one interface and asking other classes to implement that, and that's the way you are creating one interface with multiple implementations. So that method is called polymorphism in OOPS. There are two type of polymorphism: static and dynamic. So static polymorphism can be achieved in a single object, and dynamic polymorphism can be achieved when you are inheriting the behavior from the existing object. Next concept is messaging. Whenever we think of a project, a module, one object cannot fulfill the whole need. That is a place where you need many objects, and it is required to communicate among those objects. So one object will be passing message to another object. So if you see this example, there is object interface and other objects. So object interface, it has few methods and data, and other objects, they are trying to communicate with other objects. So messaging is very important feature of the object oriented programming, where you are sending where objects are doing the communication among them. So messaging is to communicate to other components to fulfill the need of whole application. This is a technique of invoking the behavior to use. How a method, whatever method has the activity, how we can use those activity, we have to ask that object. How we are asking, we are sending a message, we are communicating through a object to a object to get something done. Sending or receiving message from one system to another system, or broadcasting it. So one object is keep on sending, keep on broadcasting one method outside where any other object can consume that. So this is where messaging comes into picture. We have seen in our real world a lot of applications are built on web service model, where an object, or you can say a user, who is again an object, who is sending some signal, who is sending some request to a system in web service model way, and getting the output from that web service. So this is the place where communication is being placed. Synchronous and asynchronous messaging model. So when you are sending a message, you are getting the response immediately, that is synchronous. If you are not getting the message immediately, and it is your request is being handled in the background, and after some time you will be notified the response of your request, that is called asynchronous way of messaging. Flow based computing. Suppose you are making a big application where you have certain module, where you have certain flow, like stepwise flow. So in first step, whatever object is being formed, it is sending some message to the second step, and so on. So that way messaging is very important feature of the object oriented programming. Delegation. If you see this example here, I delegated all my responsibilities. Now there is nothing to do. What does mean in your ops? What exactly it mean in our object oriented programming? It means that delegating the job to other object when an object receives some request. Suppose you are requesting, there is one object which is receiving some input. It is receiving an input to add two numbers. So what it does, it does not do anything on own. It calls some method of other object. So it is delegating your request to other object. So this is the place where delegation comes into picture. So delegation is something alternative of inheritance. So inheritance, what happens, your child object can take the request and pass to its parent. But in the case of delegation, it is an alternative of inheritance. It is being achieved by aggregation and composition. So aggregation is and composition are the again relationship between those two objects, where one object is passing the information to delegating the information to other object, delegating the request to other object to perform the activities. This is a relationship among objects. That what relationship is called aggregation and composition. I will explain aggregation and composition in detail when I will cover in Java courses. And it provides reusability. So basically you are not writing a particular implementation on each step. You are trying one at certain step, the implementation of one logic has already been written. You are trying to delegate the request to that label to complete that request. So that way you are providing a lot of reusability. This concept is called persistence. Persistence is nothing but you are also saving your objects, you are serializing your object at some place. Most time it is database. So suppose you have database and you have your object. Suppose you have employee object, you want to save it into your database. So object oriented programming gives a concept of object oriented database where you are saving your object. So in database you have something called table, and table has row and columns. So one object is corresponding to a table, and the one row denotes one object. So suppose you have employee as a object, so each row has one employee, and the columns of those table is corresponding to attributes or property of the object. So object database model that added a new capability that is called persistence in the OOPS. So how it helps? It helps persisting the object and assessing and querying on them. Next concept is object life cycle. Object life cycle means once, suppose I am creating one class, and as I said, object is the instance of a class. I create one object, initialize it, then use its method or whatever activity it can perform. Then after that I will destroy it. So what does mean here in programming language? It means that whenever you are creating the object, you are allocating some memory into the space, some space into the memory for that object. So, and after using it, you are deallocating the space from the memory. So those things are achieved by object lifecycle in OOPS. What are the languages that support object-oriented programming concepts? So if you go to this link, what I listed here, you can see it is close to 100 programming language that supports object-oriented programming. Few of them like C++, C Hash, Python, Java, JavaScript, .NET, COBOL, Cobra, Lisp, Java, Perl 5. So out of these languages, few of them supports fully all the features of object-oriented programming, and few supports less. Out of these languages, I am going to explain about Java in our coming courses. So, what we have done so far? So, we have understood that OOPS is nothing but it is all about object and class and their behavior and communication. Everything around us can be treated as an object, where you can think of any object which has certain attributes and some activities on those attributes. OOPS map a real world problem, and it has a lot of concepts that will help you to design the solution. Messaging, persistence, and reusability are the most beneficial concept of OOPS. So I think now we are good enough in understanding of the OOPS concept, and now we can jump into programming language, say Java, to understand Java and relate those concepts with object oriented programming, where we will see the practical approach to understand the object oriented programming concepts. So these are the places where I have tried to get all those information which I am sharing here. I hope you have enjoyed this session and you have learned something from here. Thank you so much.